Welcome back. In this section, we'll be covering the AnyConnect remote VPN client as well as ICE, or the Identity Services Engine, which provides visibility and can help a customer secure their network in a number of ways. AnyConnect provides seamless and secure connectivity for an organization's remote users. With today's user becoming more mobile, they also need the ability to connect back to the corporate environment in order to remain productive. This creates a challenge for corporate IT as to how to deliver this experience while also maintaining a secure connection. AnyConnect authorizes and secures the connection between the remote user's endpoint and the corporate network through an encrypted tunnel, keeping both network access and data secure. However, AnyConnect is more than just a means of transport. It also integrates with other Cisco security solutions. To highlight a few, AMP can be deployed through AnyConnect to provide threat protection for the remote user. The Network Visibility module in AnyConnect, which integrates with StealthWatch, can be used to give visibility into a remote user's traffic in order to identify any abnormal behavior which might indicate a threat. And then Umbrella can also be integrated into AnyConnect to provide off-network protection for when the user is not on site at the office. All of these security integrations help to protect the remote user, allowing them to remain secure as well as flexible and productive. ICE provides visibility into users and devices, as well as the ability to apply centralized network access control. ICE can also integrate with a number of other Cisco security solutions. We're going to be talking about one such solution that deals with network behavioral analysis later on in this section. As more and more devices are allowed to connect onto the corporate network, organizations start to lose sight of exactly who and what is accessing their network. In one report, 90% of organizations said that they were not fully aware of all the devices on their network. These blind spots can then quickly translate into security threats. So basically, if you don't even know what's on your network, it's going to be an even bigger challenge in order to set the right access policies to secure it. ICE can help with this access challenge. First, from network visibility, understanding who and what is trying to get onto your network. And even better, having the context to know where they are and what access method they're using. And then using this contextual information to define the right controls to grant these users and devices the right levels of access on the network. And then maintaining network protection even after they're granted access by keeping track of what they're doing. And this is the area where the ability to share information between different vendors' devices is essential in implementing an effective intelligent security architecture. ICE can apply centralized access policy control no matter how that user is connecting, whether they're doing a wired connection, a wireless connection, or over VPN. Then those same policies can be deployed throughout the entire organization, no matter where that user is. So whether they're at the headquarters, whether they're at the branch, or whether they're connecting remotely. ICE essentially works as a gatekeeper. Within a given network, there are usually a lot of different roles of people trying to gain access to the network. ICE can be used to grant these different people different levels of access onto the network. So for example, allow guests access to the internet, but allow contractors access to the internet plus certain internal allowed resources. This type of granular policy control allows ICE to grant the right user the right access to the right resources. In addition to enterprise-wide access control, ICE can also be used in a number of other use cases. With today's user becoming more mobile, requests for guest access are becoming expected. And the organization needs to be flexible in how they choose to implement this type of guest access. So maybe they want to retain a lot of control and be able to report on what each of these users are doing. And this might be something where you're at a corporate office and customers come in. Or they might just care about deploying simple internet connectivity. This is something you might see at a coffee shop. In addition to guest access, ICE can also help in BYOD deployments, where employees are allowed to connect their personal devices to the corporate network. And when ICE is used in conjunction with a mobile device manager, these devices can also be checked for compliance. So checking to see if they have the necessary applications installed, or if they have the minimum operating system version. And if these devices do not meet requirements, ICE can enforce access control and choose to deny these non-compliant devices access to the network. We have two other use cases, TrustSec and PXGrid, which we will be going into shortly. As networks expand and become more distributed, access policy definition can become very complicated. ICE plays an integral part in the TrustSec solution, which helps to automate and simplify network access and segmentation. So the way it works, when a user is granted access to the network, they're assigned a tag. Then within ICE, this tag is assigned to certain allowed resources. The knowledge about this TrustSec tag is propagated to the other devices within the network. So they basically know whether to permit or deny certain traffic. So in this example, a doctor is assigned a blue tag, while the receptionist is assigned a green tag. The doctor is allowed to access certain confidential patient records, while the receptionist is not. All the devices in this network are TrustSec aware, so they know that these patient records correspond to a blue tag. So when the receptionist's green tag traffic tries to access these resources, the switch will deny it. TrustSec serves to make access policy definition and control more logical, being able to say this user gets access to resources A and B, but not C. In addition to TrustSec, ICE also plays a key role in the StealthWatch solution. So one of the challenges in securing networks today is that merely using technology like firewall, IPS, and AVC just isn't enough anymore. These threats are becoming so much more sophisticated that they can sometimes evade initial detection. And when that occurs, they can spread very quickly and quietly throughout the entire network, and the perimeter devices might not have any idea it even happened. That's why it's necessary to have the real-time visibility built into the network in order to be able to detect suspicious behavior that might indicate a threat. So the way StealthWatch works, NetFlow data is continually being collected from the different devices in the network about communications. So these devices might be routers, switches, firewalls, or remote users. All of these records are then aggregated and correlated and basically analyzed for any suspicious events like data exfiltration, meaning that data is being stolen from the network. Then we can add an ICE, which provides user and device context. So then StealthWatch can trigger ICE to basically quarantine this user if there's any indication that their device has been compromised. This solution provides the insight and intelligence to understand and identify suspicious behavior which might indicate a threat. This allows the organization to better react and protect their network. ICE also plays a key role in other Cisco solutions as well as the StealthWatch solution. This allows information to be shared and for ICE to adapt its access policies based on what other devices are seeing. And this information sharing, it's not only limited to Cisco devices. One challenge today that enterprises face is that they might have a lot of security vendors within their environment. And all of these disparate products, they usually work independently of each other, so they can't share information. But now with PXGrid, which is a feature in ICE, now we can share information with different third-party devices, such as ones that do event management or performance management. PXGrid is a framework that these different devices can authenticate to. They can then push their own information feeds onto it, as well as subscribe to the feeds of others. Then they can use this external information in their own security determinations. PXGrid automates the ability to detect security events faster. This enables simplified management, reduces operational cost, and enables greater network integration. ICE is extremely versatile. It's designed to share information and take action based on what is happening in the network. And with the rise of new trends like IoT and cloud, coupled with the emergence of new threats, and then having insight into what devices are trying to get on the network, as well as having intelligence about what they're trying to do on it, this is essential in being able to implement an effective integrated threat defense architecture. This ends this section on AnyConnect and ICE.